Welcome to MH2801 video segment on the branch cut of a multi-valued function. In the previous video segment, we have talked about how a multi-valued function can be thought of as a single-valued function on a Riemann surface. However, a Riemann surface is not exactly the most convenient object to deal with if we have to perform complex contour integration. This is why we need to learn how to introduce branch cuts to a Riemann surface so that we deal only with one single branch of the Riemann surface on which we can define complex contours to perform our integration. Now, since I am not capable of sketching the Riemann surface of ln Z, I have stolen this from Wikipedia and to use to illustrate how to create a branch cut. Okay, so now a branch cut, the Riemann surface of a complex function is of a multi-valued function is of course unique in the sense that if you talk about the real part and the imaginary part, they are unique surfaces. However, there is no unique branch cut to a Riemann surface. I can introduce the branch cut in many different ways. But first, let me talk about how to introduce one specific branch cut to the Riemann surface of the complex logarithm. Now first imagine you have a gigantic scissors. Okay, and you are going to cut along the dotted lines. So what you will do is you will start out at complex infinity and follow the dotted line in. Okay, so you cut towards the branch point of the Riemann surface of the complex logarithm, and when you reach the branch point, you should follow it upwards. Okay, so this underneath, you can't see it because it's obscured by the complex Riemann surface, and then you follow it back out again. Okay, and then you would end okay, so here you would have, you start out from the complex infinity and you will end at the complex infinity but of a different branch. So once you have done this, what you do is you grab hold of this piece of this branch of the Riemann surface and you yank it out, and then you would have just one single branch. Of the Riemann surface. Okay, if you now want to define complex contour integrations, the contour you define must now lie entirely within one single branch. You are not allowed to go across this branch here or across this branch cut here. So that is the purpose of the branch cut. It is supposed to stop you from ever defining contours that make excursions beyond a single branch. Okay, now of course this is how the branch cut looks like on the Riemann surface. On the complex plane itself, how does the branch cut looks like? So here we have x equals to the real part of x, and then y is the imaginary part of z, so this is not x but z. Okay, now what does the branch cut we have introduced, how does the branch cut we have introduced look like on the complex plane itself? So if we have cut along the positive x-axis, then what it will look like is it will look something like this. We have made an incision here, and then we came back out. So we reached the branch point, which is at z equals to 0, and then we came back out again to complex infinity, and that's all. So this is the branch cut that we have introduced to the Riemann surface of the logarithm function. Now, this is not the only branch cut that we can make in order to just be able to pull out one single branch of the Riemann surface. We can also make an incision along a totally different direction. So let me illustrate how that works. So I can also come in along here. So I bring my scissors and I cut in along here until I reach the branch point, and then I come back out, and I come back out this way, and I will still have isolated one single branch of the Riemann surface that can be then detached from the complete Riemann surface. And of course, once I've introduced these branch cuts, I must ensure that I do not make excursions across these branch cuts. So on the complex plane itself, this new branch cut that I have made would approach the branch point from the negative y-axis, reach the branch point, and then come back out again along the negative y-axis, which is the imaginary part of z. So this is another branch cut. Okay, so I'm showing you all this to make you aware of the fact that branch cuts are not unique. You can define any branch cut you like. I can also define, for example, another branch cut that runs in this weird direction. And in fact, it does not have to be a straight line. It does not have to be a straight line at all. It can be along a curve. Okay, as long as I make sure that I isolate one single branch of the Riemann surface. So these are all valid branch cuts, so long as I satisfy the condition that I isolate a single branch of the Riemann surface, and once I have this branch cut, I just need to make sure that I do not make excursions across the branch cut.